Hello, everybody. Thank you all so much for being here today, and thank you to the team from Carto for hosting. It's really great to be here and be back in person in the great city of New York and see such a showing today, especially to be here in what's now my home city. So it's a real honor for me to be representing not only the AWS Data Exchange service team, but also to be joined by some of my colleagues who've flown in from across the country to represent some of the many new developments coming out of AWS that support Geospatial. So in my role here at AWS Data Exchange, I work closely with our customers to really understand their location data needs and promote and position the right location intelligence solution, as well as drive new opportunities to the providers that choose to list on the Data Exchange. Okay, so we're going to be stationed just off of the main floor. We have a booth here today. We encourage you to all come and greet us throughout the breaks throughout the day. And if anyone's wondering about my accent, no, I'm not from Brooklyn, but I'll give you a clue. My home country is south of the equator, and our national rugby team are the current reigning world champions. So a little geo-trivia there if you can figure that one out. So jumping right in, I'd like to begin with this question. Why cloud infrastructure? And more specifically, why is the cloud so important to the work you all do as geospatial professionals? In his keynote, Javier touched on some of the many benefits of moving to the cloud. Benefits like IT performance, scalability, reliability, and cost effectiveness. And it's true, moving to the cloud is allowing businesses to innovate faster because they can focus their valuable IT resources on developing the applications that really differentiate their business and improve customer experiences, instead of focusing on the undifferentiated heavy lifting of managing IT infrastructure and data centers. And with the increase in the frequency and volume of location data and the attributes that were being collected, I think this is especially valuable to the work you all do as geospatial professionals, where your work often relies on massive amounts of data and compute resources. And why are customers choosing AWS? I'm sure many in our industry are already familiar with AWS, and likely many in this room use our services on a daily basis. And for many customers, millions of customers across the world, including fast-growing startups, large enterprises, and leading government agencies, are using AWS to lower costs, become more agile, and really innovate faster. So today, AWS is the world's most comprehensive and broadly adopted cloud platform with over 200 fully featured services powering use cases across industries. And geospatial, many of these services provide geospatial capabilities already, either directly with a multitude of storage options such as Amazon Redshift, S3, and Aurora, or through Amazon Location Service and Amazon QuickSight for data viz and querying. Or indirectly through the support that we provide for existing enterprise and open source software capabilities. And when you tie this all together with the vast amount of geospatial data available through programs like the Registry for Open Data on AWS and the AWS Data Exchange, it's now easier than ever for you to do your geospatial analytics natively in the cloud. And I know I don't need to tell those in this room this, but geospatial is everywhere. It would be difficult to find a vertical that doesn't use location data and analytics in some capacity, with the applications of geospatial information and technology prevalent across these industries and many others. And across all these industries, it's data that's the underlying force that fuels the insights and innovations, the insights and predictions that lead to innovation and better decision making. But according to this McKinsey report, what's really slowing down this pace of innovation is the fact that the data teams are spending up to 80% of their time on sourcing and preparing data for use instead of on the actual business differentiation task of data analysis. So why is that? Well, because finding the data you need, acquiring it, preparing it for use, it's time intensive, it's labor intensive, and it's just plain difficult. So even though a lot of the world has changed over the last 20 years, our primary methods for exchanging data really haven't. So while cloud has allowed customers to build applications, perform spatial analytics, and deploy sophisticated machine learning, all cheaper, better, and faster, Anytime a business relies or depends on third-party data, they typically rely on this old way of transacting. So those looking to procure data, have to make a number of decisions. Where are they going to source the data from? They're calling potential providers, soliciting samples, validating those samples, trying to understand terms and conditioning, pricing, and then they still have to set up the integration. And the data could arrive in any number of sources. It could arrive in a DVD, an SFTP, a hard drive. And then once they license that data, engineers are spending weeks to months building pipelines to ingest, validate, and transform that data. And this is a real distraction when all you want to do is use data to answer your most burning questions. So we heard from customers that they wanted the same experience finding and acquiring data to be as easy as it is to shop online today. So in the same way that sort of machine learning and app development have all been simplified and democratized with cloud technology, exchanging data should be too. Subscribers should have a place where they can go to procure all the data they need in whatever format they need it. They shouldn't have to jump through hoops to set up subscriptions, contracts, and billing. And they shouldn't need to invest months of time building these pipelines to prepare data and bring it into their production systems before they can start using it. So in 2019, we launched AWS Data Exchange to bridge the gap between subscribers and providers exchanging data. So AWS Data Exchange really makes it easy for organizations to find the data they're searching for with our comprehensive catalog comprised of over 4,000 publicly listed data products across 250 data providers. And to make it even simpler to find and subscribe to free and open data, in June of this year, we integrated over 300 publicly available and cloud-optimized data sets. So we added these to the catalog. That's petabytes of data over 14 categories, including climate forecasting data, satellite imagery, and weather observations, across many more, actually. So if you're familiar with the Registry for Open Data on AWS or the Amazon Sustainability Data Initiative, those data sets, which are freely hosted and available to you as AWS customers, are now discoverable within the AWS Data Exchange. Data evaluations also made easy. We have over 1,000 sample data products that are just a few clicks away. So if you want to do an evaluation, over 1,000 products are available today. And we also support custom and private products for those customers requesting data that's not in the public catalog. So if you're dealing with a provider and you want a custom or specialized piece of data set or just a slice of a master data set, they can transact with you directly in a private fashion. So in the catalog today, you can find many of the most valuable data sets needed for your geospatial use cases. And we do so in partnership with a number of businesses that are actually present here today, including, of course, Carto, as well as Foursquare, Precisely, PredictHQ, really fascinating, interesting new company based out of New Zealand with a global team. They're present here today, as well as SafeGraph, to name just a few. So for these businesses, the data exchange is really a secure and compliant channel that allows them to reach new audiences and grow their business. And even if you're not a commercial licensing business, you think you have a data product that could have value in the market, please come and speak to me. If you're using AWS today, it's very easy for you to become listed data providers. So on the other side of the equation for subscribers, the data exchange offers this consolidated marketplace to search for, subscribe, and use third-party data in the cloud. So this means less time spent building infrastructure to get your data into production. And you're also ensuring that the data that you acquire through the exchange is compliant with industry regulations. I think this is especially important given the climate today and the sensitivity around location data. And with native integration across AWS, engineers, analysts, scientists can start using the data the instant it's licensed. And for those customers with private pricing agreements, right, otherwise known as enterprise discount programs at AWS, 100% of the subscription cost for purchases of data through the AWS Data Exchange are counted towards your spend commitment with AWS. So what this means, it's an incentive that allows customers to migrate their data spend over to the Data Exchange and benefit from greater discounts across AWS services. So today we're proud to say that the Data Exchange is the most comprehensive data marketplace by delivery type. allowing customers to take delivery of data via files, tables, and APIs. So when we launched back in 2019, we launched with the most widely requested data type, which is versioned file-based, right, files, exported directly to Amazon S3. But over time, we heard from customers that, building this pipeline that will automatically ETL files into production-ready tables was taking a significant amount of time and engineering effort. And subsequently, analysts were still waiting weeks to months to start using their data. They asked if there was a way for providers to share access to live production-ready tables that they could start querying and analyzing and ingesting wherever they needed without all of that data prep work. So in January of this year, we launched AWS Data Exchange for Amazon Redshift, our data warehouse built for the cloud. And over the next few slides, I'm going to dive a little deeper into why I think this is so important for our industry and for geospatial data scientists. So this new delivery type lets providers license access to live production-ready tables that can be queried natively in Amazon Redshift, easily ingested into other database services, and even consumed directly from Amazon Redshift in your GIS environment without any ETL. So what this means, you can go onto the exchange, subscribe to an Amazon Redshift data share, and have that data consumed and visualized directly in your GIS environment, whether that's Carto, PostGIS, or ArcGIS, all without any ETL. So one of the key benefits here of Amazon Redshift is that subscribers are querying and accessing data the instant the provider makes a change. So rather than waiting for that provider to publish a fully revised data set or a new revision of a data set, you have access to that data the instant the provider makes a change. So the data is always up to date, it's always fresh. In this paradigm, the data provider handles all of the prep work for you, so you can begin querying and visualizing the tables as soon as you subscribe without having to set up any data pipelining. And with AWS Glue, it's easy to stream data to and from other AWS services like Amazon RDS or Amazon Aurora, as well as non-AWS services like Databricks and Snowflake. So what this means is we're allowing users to easily access this production-ready data no matter where they need it to reside. So as Javier mentioned in his keynote describing this vision for a geodata cloud, it's really the rise of the data warehouse that's allowed organizations to unify and connect all of their data in a single location. And geospatial data is no different. In 2019, Amazon Redshift added support for geography and geometry data types, making it possible to use Redshift as a spatial database engine. So companies use spatial data, right, to power decisions and gain insights about the locality of their business and services. And we call this location intelligence. And one thing that's common across all industries is that when performing that analysis, that geoanalysis, effectively combining spatial data and enterprise business data from different sources is fundamental. Redshift Data Shares makes this easier than ever by providing a seamless experience to share, enrich, and consume data. With Amazon Redshift, you can use spatial joins. We have built-in spatial functions, as well as machine learning models available directly from within Redshift using only SQL. So joining data from multiple providers with your own enterprise data without moving from one location to another is a huge advantage when we look to break down these data silos. And new value is always just a join away. The more data sets you join, the more interesting questions you're able to answer. So with the spatial capabilities available natively within Amazon Redshift, we have over 100 spatial type functions today, combined with specialist tools from our partners like Carto. A great example is their advanced analytics toolkit. It's now possible to solve many, if not most, spatial use cases natively in the cloud. And our users love the fact that they don't have to move data out of Redshift to any other system to make the most of its scalability, cost effectiveness, and interoperability. All of this is much needed given the rapid rise in volume of spatial data and analytical workloads. So our AWS customers are using a combination of purpose-built database and analytics services on top of their data lakes in S3 to solve geospatial and big data use cases better by storing and processing data in a way that's optimized for that particular use case. And for almost every type of analytics need, we have a serverless option. So by automatically provisioning and scaling capacity and paying for only what you need, and what you use, we make it easier for customers to do what they do best, right? Focus on your applications, focus on your work, and we handle the rest. And today, AWS has the most serverless options for data analytics in the cloud. So you've heard enough from me. We're going to switch gears now, and we'll do a demonstration. And really what we wanted to demonstrate with this modern architecture is what we hosted yesterday in our workshop, and I know some of you were able to join us for that, where our attendees were learning how to deploy these capabilities for a retail site selection use case. So with this architecture, you really have a seamless experience to subscribe to, load, analyze, predict, and display spatial data, all without leaving the Redshift query editor. So let's take a look. I'm very pleased to say that the solution architect, one of our senior SAs, a specialist in Redshift, his name is Sahib, is joining us here today from Chicago. And we'd love to hear your thoughts about this analysis, and if you'd like to run it yourself or have any questions, you can come and meet us outside. Thank you. So we'll dive into the demo. Hopefully this plays.
We will start by opening up the Amazon Redshift Query Editor version 2. We will connect to our Redshift Serverless workgroup and expand the dev database. Under that, we have the Carto schema, where we have already loaded our first-party data. We will expand that and see that we have some tables that have data about our first-party retail stores, as well as a list of some competitor stores. We have also already installed the Carto Analytics toolbox for Amazon Redshift, which is a set of user-defined functions and procedures organized in a set of modules based on the functionality they offer. Now we will create a new tab in our query editor and explore the first-party data with a simple query. In the result set, we can see that this table contains a record for each target store in the United States, along with the address, the longitude and latitude coordinates, store hours, and sales for the year by store. Now we want to enrich our first-party data with some additional demographic information for the area around the store so that we can better understand the factors that contribute to how successful a store in a specific location might be. To do this, we will go to the AWS Data Exchange, which is an AWS service that makes it easy for customers to find, subscribe to, and use third-party data from a wide range of providers. It is the only service that offers data delivery through files, tables, and APIs from over 250 providers all in one place. With a vast catalog of over 3,000 data products, AWS Data Exchange makes it easy for customers to ingest third-party data and analyze it with a wide variety of AWS analytics and machine learning services. We will then go to the AWS Data Exchange catalog, where we can browse through more than 4,000 data products across many different categories, delivery methods, and contract types. In the search bar, we will search for ACS Sociodemographics, and then select the 2019 Sociodemographics dataset that is available for a free subscription. This will take us to the AWS Data Exchange product detail page. We can view additional information about this data product on this page, including the type of offer, an overview of the dataset, the specific datasets that are included, the usage information, support information, and similar products. We will click on Continue to Subscribe and finalize our subscription. After the subscription is verified by the provider, we will see this data product under My Subscriptions. Now that we have successfully subscribed to a third-party data product, we will use Amazon Redshift to query it. We will go to the Amazon Redshift Serverless dashboard and click on the namespace for this Redshift Serverless workgroup where our first-party data resides. We will then click on the Data Shares tab. Here, we can see some information about how Amazon Redshift data sharing works, along with data shares created in our Redshift instance that can be shared with others, data shares from other Redshift instances in our account or other accounts that have been shared with us, and finally, data shares that we have subscribed to through AWS Data Exchange. In this last section, we can see the ACS sociodemographics dataset that we subscribe to from AWS Data Exchange is already listed. We will select it and click on Create Database from the data share. In the pop-up window, we enter a name for our new database and click Create. I can see a notification at the top of the page that informs me that the Carto third-party sociodemographics database is successfully created. This new database in our Redshift Serverless workgroup will allow us to query the ACS sociodemographics dataset alongside our first-party data. We will now go back to our Amazon Redshift query editor and refresh our connection to our Redshift Serverless workgroup. Now we can see there is a new database under our Redshift Serverless workgroup that corresponds to the one that we just created. This new database has two schemas, the Carto schema and the USA ACS schema. The USA ACS schema contains a table that has the sociodemographics data for US census blocks. The Carto schema contains a table that has the geography information for US census blocks, along with a key that we can use to join the spatial data to the USA ACS sociodemographics table. We will now run a simple query to explore the sociodemographics data that we acquired through AWS Data Exchange. In the result set, we can see the date, the population breakdown for each census block by age, the ethnicity, income, housing, education, and other attributes. Now we want to join our first-party store data to the third-party demographics data. First, we will use the longitude and latitude coordinates of our retail stores and some competitor stores and convert them to a geometry data type using a built-in function in Amazon Redshift called st_geometry. This will convert from extended well-known text to a geometry data type and store that in a materialized view. We can now use additional built-in spatial functions in Amazon Redshift on the geometry points we just created for our stores. Here is an example that uses the st_distance function to find the distance in meters between 2 points. We will compare the coordinates of the Empire State Building to the coordinates of all target stores in the United States and sort them based on their shortest distance from the Empire State Building. In this result set, we can see that the closest target store to the Empire State Building is only 367 meters away on 34th Street. We can now also use the built-in st_intersects function to find which US census blocks are each of our target stores located in. In the result, we can now see on the same record the store information alongside the sociodemographic information for that location. What we now want to do is try to find good candidate locations for additional stores based on which areas are likely to result in high projected sales. We want to use machine learning to predict what potential sales might be for stores across a range of areas around New York City. To do this, we will use Amazon Redshift ML. Redshift ML makes it easy for data analysts and database developers to create, train, and apply machine learning models using familiar SQL commands in Amazon Redshift data warehouses. With Redshift ML, you can take advantage of Amazon SageMaker, a fully managed machine learning service, without learning new tools or languages. Simply use SQL statements to create and train Amazon SageMaker machine learning models using your Redshift data, and then use these models to make predictions. Redshift ML makes the model available as a SQL function within your Redshift data warehouse, so you can easily apply it directly in your queries and reports. We're going to create a new model and use a selected set of sociodemographic attributes as input features to this model. We will also use a function from the Carto Analytics toolbox for Redshift called QuadBin from GeoPoint to create a QuadBin spatial index which we will also use as an input into our machine learning model. As part of the model parameters, we can optionally define the model type, the problem type, and the objective. We will now use Carto to visualize our combined dataset and get further insights into which locations would be good candidates for a new store. We will go to carto.com and log in to our Carto account. Once we are logged in, we can click on Connections and easily create a new connection to our Amazon Redshift Serverless workgroup by entering the host name, database, port number, username, and password. Once our connection is successfully created, we go to Maps and we create a new map. In our new map, we will click on Add Source From and select our Redshift Serverless workgroup. We will then select our target store's materialized view to populate the store locations on our map. Next, we will add in a custom query from our Redshift Serverless source to display all the US census blocks and shade them based on their total population. This is third-party data that we subscribed to from AWS Data Exchange earlier. We will now create quad bin tiles in our area of interest and use the machine learning model we created in Amazon Redshift ML to predict average sales for these quad bin tiles based on the socio-demographic information that we subscribe to from AWS Data Exchange. Now we can see the areas that are predicted to have higher revenue. We will overlay some competitor store locations on this map as well to view the proximity of competitor stores in areas where we don't currently have a first-party target store. And we can also see which areas are predicted to have good sales based on the demographics of the area. We now have many valuable data points to be able to come up with multiple candidate locations. With the geospatial capabilities available in Amazon Redshift, combined with the tools from Carto, it is possible to solve this and many more spatial use cases natively in the cloud using an easy-to-use and completely serverless architecture. Thank you for watching.
So, following the general availability of Amazon Redshift Serverless, announced back in July of this year, we launched this acceleration program. And it's designed to offset Redshift costs for our customers subscribing to data shares on Amazon Data Exchange or AWS Data Exchange and using Redshift Serverless for novel use cases. Right? So I'm challenging everyone in here in this audience today, even if you're not using Redshift, but if you'd like to come onto ADX, take delivery of a data share, we can talk about covering your Redshift spend for up to 6 months. We've also just published that previously demoed solution as a workshop with instructions that you can follow to do that analysis yourself and plug in your own data, right? Bring in additional inputs. We'll cover the cost of running that analysis. So really, if you're interested, please come and speak to me about that just at our booth off the auditorium floor. So I'm nearly finished. 90% of what we build at AWS is driven by what customers tell us matters. And since launch, the AWS Data Exchange team have continuously released new features based on your feedback. And we have some exciting new features on our roadmap that we're building to better service the geospatial community specifically. So save the date this November and join us for the annual AWS User Conference, reInvent, to be the first to learn about these and many other new features supporting the geospatial community. So like I just mentioned, innovation is driven by what you tell us matters. And if you support the vision for a geodata cloud, like I do personally, I invite this audience to really advocate for GeoParquet as a new standard and even go so far as to request this format from your data providers particularly. So with that, I'd like to thank you all for being here. Wish you all the best for a productive day ahead. And I'll hand it over to Flo, and thank you all for coming.